Okay, boys and girls, I'm going to try to do one of these problems sort of fresh. I remember doing this a couple of years ago. I think I got it. Sometimes it's useful to see someone struggle doing something for the first time. Most of these I usually work through and I kind of know what the deal is. But this one I think is relatively straightforward in its concept. We have a 10-meter length of wire, and we're going to cut this thing, and one part we're going to make into a perfect square. Wherever we cut it, we're going to take this piece of wire and bend it into a perfect square. The other bit we're going to bend into an equilateral triangle, okay? And then the area of each of these is going to be either a maximum or a minimum, okay? So we can solve this, again, at least one part of it thinking like a soap bubble. The maximum area is going to be when we take this wire and don't cut off one molecule and make it into an infinitely small equilateral triangle, but then use most of it to make a square, because the square is the most round, most bubble-like figure. This is too sharp, encloses less space than the square. So the maximum is going to be a square with the whole thing, and square only, all right? But the minimum one, that's a little bit harder, okay? If we made this only an equilateral triangle, thinking that somehow a square is bad, you'll see that just the fact that we're putting all of the wire into one shape would make this bigger than if we cut it somewhere and then make each into a smaller shape, okay? So we need a way of writing an expression that uses x and comes up with both of these areas together and then minimizes that, all right? Well, one trick is, just to make it easier, let's not make this a 10 meter or 10 whatever wire. Let's just make this 1, because whatever answer we get, we can multiply it by 10 at the end. I think that's a trick that makes a lot of this a lot simpler, that you can think about, well, whatever the answer would be, we could put it in a photocopier or something and make it larger. So makes, like I said, the math simpler. So I'm going to cut this length of 1 meter, 1 whatever, by x. And what is this area going to be? Well, I would take and divide that x by 4, okay? And then I would square that. And so it's going to be 1/4 x squared is going to be this area. Plus, okay, so this one is a little bit trickier. This is why it's worth knowing your shortcut values, that it's going to be whatever this length is. In this case, it's going to be 1/3. We cut that in half, and that would be that length. So that's going to be 1/6, but it's not x, it's 1 minus x. So I'm writing it small, but it's 1/6, 1 minus whatever x is. That's that length right there. The hypotenuse then would be twice that, but we want to know what the altitude is, and that's that times the magic multiplier, radical 3. So it's 1/6 times 1 minus x times this same thing times radical 3. So that's going to be that squared times radical 3. All right? That's that area for that little triangle right there, okay? And then I would multiply it by 2, but then I take half of it. So if I multiply it by 2 and take half of it, I get exactly that, okay? So here's the area of these two shapes, all right? That's the area based on x as a function of x, okay? Now I'm going to take the derivative of that. I can just tidy it up a little bit in that, well, when I take the derivative of this is just going to be 1/16 x squared. When I bring the 2 out front, that's going to be 2/16 x. So that's 1/8 x when I take that derivative. Plus then, this is going to be 1/36, and then 1 minus x squared, okay? And then times radical 3, I'm just going to put that there. So it's radical 3 over 36 times 1 minus x squared. When I take the derivative of this, I'll put a little prime thing like that. I've got then 1/8 x plus radical 3 over 36, and then that's going to be times, bring the 2 out front, and it's 1 minus x to the 1, take the derivative of the inside, and that's minus 1, and that gives me 1 over 8 times x plus, or minus, this 2 is going to cancel with that and give me 18, and that's a minus radical 3 over 18, and then that's times 1 minus x, okay? We want to set that equal to 0, so if it's a minus, it's going to be when these are equal, okay? And now I just need to solve this. So I guess if I multiply everything by 18, I'll get 18 over 8, which is 9 over 4. So 9 over 4x equals radical 3 times 1 minus x. And then I'm just going to distribute, and that's going to give me radical 3 minus radical 3x. So I want to get my x's in 2 places. So this is, I'm going to maybe run out of space. So I'm going to get 9 over 4 x plus radical 3x equals radical 3. And so then I can factor out that x, and I get 9 over 4 plus radical 3 equals radical 3, and I'm in the home stretch here. X then is going to be equal to radical 3 all over 9 over 4 plus radical 3. Okay? So that should give you the amount that minimizes the area. It would be worth typing into a calculator to see what the decimal is, but it's an odd number, so you can do that and check it in the back of the book. Hopefully it works out. All right? The lesson is just to write an equation that uses the physical reality of the problem as best you can, get it down to one variable, and then grind it out. Good luck.